Hello guys, we are going to do a very important topic of EMFT, that is to identify the type of polarization. Right, this is the main question in GATE, in ESCs and in PSUs, that which you have to identify the which type of polarization, and this whether circular, linear, elliptical, and in that the other cases that whether it's right or left elliptical, right or left or right circular. Okay, and now I'm not going to tell you the whole story about this polarization and the long method, which you might have studied in your B.Tech and in your coaching classes. I'm going to tell you the trick to identify, short trick to identify whether it's elliptical, it's circular, or it's linear polarization. For that, I want to first tell you the one thing, that if we write the electric field, we'll write it like that. This is the first component, this is the second component. First component in x direction and second component in y direction. So we'll write it like that. This is the real part of right part of e to the power j omega t minus beta z. And if it is minus here, that means the z is going, it is going in the positive z direction. Wave is going in the positive z direction, and electric field is in the x direction and y direction. It's one component is in the x direction and other component is in the y direction, but the wave, the main EM wave, electromagnetic wave, is propagating in the positive z direction. And if I write it here, the omega t plus beta z, then it is in the negative z direction. That means the EM wave is propagating in the negative z direction, right? Or it may be like that: E is 1 e j omega t minus beta z dx cap, or in this type. Okay, you will get the question in both this type or in this type. And before that, you have to learn this, that if the phase difference between the two components, that is that E01 and E02 is 0 or 180 degree, then it's a linearly polarized. Okay, and if the difference is plus minus 90 degree and both the components having same amplitude, then it's a circularly polarized. And if phi is not equal to 0, or it's not equal to 0, means it may be anything, or it's not equal to plus minus, it's equal to plus minus 90 degree maybe, or it can be 60 degree, 80 degree, anything, then E01 is not equal to E0. This is the main thing. Both the amplitude should not be equal, then it's a elliptically polarized. And where in this equation, if somebody written in somewhere that -1 is written, then you have to write it like that, e is power j pi, because it's -1. Okay, and if it's written j, then you will write it like that. It will help you to solve the questions. So these are the few questions which we are going to solve, and it will cover whole the type of polarization. So first question we are going to do is this one. That is the first question. E is equal to 0.5 ax cap plus ay cap e j pi by 2 and e j omega t minus beta z, or it's kz. So first thing you have to identify is first that what's the sign here. It's negative, means the wave is propagating in the positive z direction. So okay, you identified one thing. And second thing, you identify the phase difference. You are getting here, there is no here there is a phase pi by 2, because we can open it like that. E is equal to 0.5 ax cap e is the power j omega t minus kz plus ay cap is the power j omega t minus beta z plus pi by 2. Okay, this equation, I have opened this equation like that. So it means the y component is 90 degree ahead than the x component, right? So we got that first thing we write in the wave is propagated in the positive z direction. Okay, second thing, phase difference is 90 degree, positive 90 degree, and which one is leading? Y component is leading, then x. Another thing, E01 is this one 0.5 and E02 is 1, which is not equal to, they are not equal. Okay, so if the phase difference is 90 degree, then it means it's not 0 and it's not 180. It linearly polarized, it's not a linearly polarized, right? So another thing, phase difference is 90, so we think it like circular, but no, because the amplitudes are not equal. So one thing we are getting from here, that it's an elliptically polarized wave, right? But the another question is that whether it's right elliptical or it's left elliptical. Okay, for that we do one thing, we made the diagram like that. This is y and this is x. So y component is leading. Which component is leading, we'll move from that component to the lower component which is lagging. So which one is leading? Leading means bada, kind of, you have to remember that. Okay, so y is bigger than the x, it's leading, so we'll make the diagram like this. And here the amplitude is in y1 and -1, and it's 0.5 and -0.5, and we'll make the diagram like that. But this one is okay. And then the one thing you have to notice is that from which hand you get your thumb in the outward direction. Okay, with this hand, no, because direction is this, so we'll use our left hand. I use my left hand to finger my thumb in the outward direction. So the hand from which we are getting our thumb in outward direction is the direction of the EM wave. So it is in the it is the direction of the polarization. So it's my left hand. So it says left elliptically polarized wave. This is how you have to identify. So I am concluding it, or I am summarizing it again. That first thing you have to check whether it's in direction positive x direction, or wave is in positive z or negative z. So you're getting it is in a positive z direction. First thing you check it out. Then secondly to check the phase, and third you check the amplitude. Okay, that they are equal or not. Then which one is leading. And for example, in this question, if it's like positive here or positive here, okay, then what will be the answer? And if it's positive here, the method which I have told you will get opposite. When it's in a positive z direction, we are getting it left elliptically polarized, but now I have used here the plus sign, so that means the left will change to the right elliptically polarized. Elliptically polarized is the right thing. Whether left or right, you have to identify by using this. The method which I am telling you is for the negative, is for the positive z direction. Okay? And if it is written positive here, so it means wave is traveling in the negative z direction. So it will change from left to right. We'll do these questions again. And now the next question is this. AX cap this. Okay, I'll show it in a. The question is this one, right? First you identify that the direction of the EM wave, it's negative here, so it's positive direction. So likewise, which I have told earlier, you have to do by that method. We don't have to reverse it because it's a positive z direction. Wave is traveling in the positive z direction. And another thing, you check out the phase again. The y is in leading phase, so it's like y is in leading phase. Leading will move towards the lagging. Okay, and the amplitude here is same. So phase difference is 90 degree. Amplitude is same. It is in a positive. And which hand I'll use to point my thumb in the upward direction? I'll use my left hand. Okay, this is like this. So it is in. So this wave is left circularly polarized wave. Okay, another question is this, and here first we see the direction of wave, it's a positive z direction, right? No problem. Then I will see the phase. Phase is 60 degree, means it's not circularly polarized, because for circularly polarized phase must be 90 degree. Then you will see the amplitudes are not equal, so you got it that it's a elliptically polarized wave. and whether it's right or left, you will check by that method. Which one is leading? Y is by leading by 60 degree, but leading. Okay, this is Y and this is X. Okay, so you will use your which hand? You are using your left hand. Okay, so it's an left elliptically polarized wave. Okay, now the next question. I've already told you when you'll get in the question the -1 sign, then you'll use the -1 equal to e to the power j pi. So I'll use here 5 e to the power j pi e j omega t plus 2x plus 5 e j omega t plus 2x az cap, and here ay cap. Right, so the this one is same, and the direction of the wave is, first of all, what is the direction of the EMF? It's negative x direction. Okay, and electric field components are divided in y and z direction. Okay, so here the phase difference is, you are getting that the phase difference pi, that is 180 degree. So at a time you will get the answer that it's a linearly polarized wave, because the phase difference is 180 degree. For example, that it will tell you find the angle with which it is linearly polarized with the direction. So for that you have to find the slope, and it's -5 and it's 5, so slope is Ez component divided by Ey component, that is 5, and by 5 is equal to -1. So it be like, this is the -1, right? Angle is 135 degree. So this is the linearly polarized wave. Okay, now we'll do the another question. I'll write it on the another page. Another question is E is equal to 5 minus ay cap plus z az cap e j omega t plus 2x cap. For minus, I have already told you have to use 5 e to the power j pi ay cap. For j you have to use e to the power j pi by 2 az cap e j omega t plus 2x. Right, I'll open it down. 5 e to the power j omega t plus 2x plus pi, right, plus 5 is the power j pi by 2 plus omega t plus 2x az cap, and here it's ay cap. Right, firstly we'll check the direction of the EM wave, and it's negative x, right? It's negative x. So the method which I have told you, you have to reverse it. First we'll do that by the same method, then we'll reverse the direction. So here you are seeing that y component is 180 degree and z component is 90 degree. Which one is leading? Y component. And one thing I tell you, when you will make the graph between x and y, you will do it like that, y and x. And when you will make the graph between z and y, you will make it like z y. For seeing your hand in upward or downward direction, for seeing your thumb in upward direction, you have to make it like that. Okay, and like this, right? So another one is the question is y is no, in that which one is leading? Y is 180 degree and x is and z is 90 degree, so y is leading. So which one is leading? You have to make the direction like that to the lagging. So it's leading, right? So you are using your right hand to make the thumb. So right, but the difference is, this is 180 and this is 90, so phase difference is 90 degree. So it's, and the amplitude is same, 5 and 5, so it's circularly polarized. But I have already told you that if the wave is in the negative direction, then you have to change your reverse the direction which I have told you. The direction we are getting is right, but the way this direction is then if the wave is propagating in the positive x direction, but the wave is propagating in the negative x direction, we have to reverse the direction. So it's a left circularly polarized. So these are the few questions. I'll give you one more question. You will post the answer in the comment section. These are some GATE questions. So here you can see that we'll do it in 1 minute. Okay, so you are seeing that the direction of the amplitude of the two components is same, that is E0, and the is same, and there is no phase difference between these two, because see, this is AX, this is here, and there is no phase difference, so it's a linearly polarized wave. This is another question from GATE. So it's 0.5 x cap y e to the power j pi by 2 this, and you are seeing that the x component, the y component is leading by pi by 2 from x component, and the amplitudes are not same. Here amplitude is 0.5, here amplitude is 1, so it's a elliptically polarized wave. And here the in options there is no option that whether it's right or left, so in comment section you will tell me that whether it's right elliptically polarized or left elliptically polarized. And this is the next question, which you can give me the answer in the comment section. Okay, thank you.